All right, great crowd. Love to see this many people showing up. So I'm going to start out asking you some questions. All right, easy. Raise your hands. Who's already a Talend customer? Okay. How many of you guys are actually developing code in Talend, whether you're a customer or not? Okay. All right, now those who haven't raised your hands yet, have you at least gone onto our website? Okay. All right. Well, today I'm going to be going over some technical material for developers. Job design patterns and best practices. Okay, so even if you played with it just a little bit, or if you just finished the training, this is a good time for you to get some of this material, because we'd rather you guys started out on the right path rather than to have me come back in and put you on the rails later on. So I think I need to raise this up a little bit. So today I have, it's about a 90-minute presentation. We're going to go through high-level SDLC and how that factors in, development guidelines. We're going to go through 16 best practices. These are the basic foundation on which I hope you guys develop your code. And we're going to finish up with some secrets, some tips, some traps in the Talend. And questions I encourage at any time. Okay, as we go through this presentation, I'm going to be switching from practice to practice. And if you got a question on one slide, go ahead, raise your hand, interrupt me. That's the best way. Really what I want is a dialogue. Okay, I'm doing this to enrich the community, because I want the community, you guys, to go out and adopt, adapt, and iterate, and even expand on these best practices. You don't have to do it always the way I suggest. Instead, take this as a basis and build upon it. I'd really love to see the community globally seize this information and expand on it. The reason is because when I joined Talend about 2.5 years ago, I asked my boss, I said, well, can you point me to some material on the best way to build jobs in Talend? And he basically said, well, we don't have anything. We have the documentation and we have the help center and okay, go write some. Great. So what did he have me do? He had me write some blogs. That's where I started with this journey almost 2 years ago. Now let's see, there we go. So I want to invite you all to go out to the talend.com website, where you will find a blog link. And about 2 years ago, Talend started writing more technical blogs. Yes, sales and marketing blogs are still there, competitive analysis and all that stuff. But I started writing a series that has become 4-part series on job design patterns and best practices. Today, we're actually going to cover part 1 and part 2. So sorry about that. It's about 4 hours of content if we do the whole 32 set of best practices. What's that? Go ahead. He said. Well, if you got 4 hours, I've got the content. But you can read the blogs, okay? And everything that I'm going to be talking about today, you will find in these blogs. I have a tendency of writing long-winded blogs, so they take about 5 or 6 minutes to read. But the good news is people are reading them. I'm getting stats from our marketing team that some of these blogs are very active, and people average read is about 5.5 minutes, which means they're reading to the end. And that's great. You will find links to part 1, 2, and 3. So start at the beginning and move forward. That'll be great. I've done blog series on Data Vault, data modeling, and I've done a new series, part 1 and part 2, on data modeling design and best practices. I actually condensed 50 years of history of the data model methodology into 4 paragraphs. Took a little research, but I think I did it. I hit on the key points. All right. So my name is Dale Anderson. I'm currently the regional manager for the Customer Success Architecture Group. We're a global team. We have about 10 people worldwide. I have 5 here in the US because the US is growing so fast. I joined 2.5 years ago, but prior to that, I was a consultant out in the field, and when I found Talend in 2009, I never looked back. I'd done SSIS, I'd done Informatica, I'd done Clover, I'd hand-coded, I'd done it all, I'd been there, I've been actually in the industry for over 35 years. I'm a database architect by trade. Business intelligence, data warehousing, that's what I do. So Talend was a natural fit for me. And when I joined in January of 2015 as the first US CSA, I was thrilled. It was a perfect fit. I was put into the lead role last year, and I managed to convince my boss to make me the manager of the US. So that's what I'm doing today. I have 2 CSAs on the East Coast, 1 in Texas, and myself and 1 other in the West Coast. So again, I want to emphasize, make this a dialogue. Don't have me just stand up here and talk the whole time. Perfect. What?
So you've been around a long time, and I understand that. So what made you fall in love with Talend? What set Talend apart for you from all the other?
That's a great question. So he's asking, why did I fall in love with Talend? What set it apart from the other tools? Well, it depends on which tool to compare against, right? And I was doing Informatica at the time, and I always struggled with Informatica because I had to deal with 2 separate parts, and I had to rely on other people to put the pieces together. And frankly, I wanted control. I'm a developer. I need to know exactly what's happening. So when I found Talend, and it does everything together, both the workflow and the data flow in a single canvas, and I love this concept of painting code. We'll talk about that. It was a no-brainer for me. I mean, I'd done more SSIS than Informatica, so the switch to Informatica was a struggle. Never really liked it much. So SSIS worked great as long as you weren't doing anything outside of Microsoft, right? And I was, so that was a struggle. Talend, open source, it generates Java code. It doesn't have this interpreted layer in between. So yeah, it was a great fit for me, okay? All the reasons why I hope you guys have been looking at or choosing Talend are the same reasons that I chose Talend. All right, so I ask one question right off the bat. What is the best way to write a job in Talend? And I don't care if you're brand new to Talend or you're a veteran. You're a seasoned programmer or just coming out of college. This is the valid question because you're working with the technology and you want to make sure that it's generating the right Java code in the right way. And since we don't actually go in really muck with the Java, we have to build our jobs in the best way possible. And they need to be 3 things. I learned this in college. It's got to be easy to read, easy to write, and easy to maintain. But how do you do that? There's always a sacrifice. Something is going to give. So how do you choose? Well, ask another question. Will the job change over time? Likely, right? So prioritize those 3. Make it easy to maintain first and foremost. Because you're going to be coming back in, you're going to be making changes to it. So if you write the code up front with the expectation that it's going to change, you will think about your job design differently. And yes, it will cost you a little bit more time to write that code. It'll be a little bit harder to write that code, but for a good reason. If the job will never change, in other words, you've got a one-off, get it done, your boss says, I need this by tomorrow, fine. Just go in and write the thing. It's a throwaway, right? Won't it ever change? I wonder about that. And the third one is, you have a team. There's multiple developers who are all going to be touching this code. So I think the priority should be make it easy to read. Make sure anybody can come into that job and figure out what it's doing just by looking at it. And we'll talk about some of those best practices. Right? So yes, maintain that code. Those are really close. Right? It's going to fall off. But if you make it easy to read, boy, you'll be glad you did, because 6 months ago when you're the one coming back in to make that change, you'll know what you did because you made it easy to read. And here's why. In Talend, we paint our code. We have a canvas. We have a palette of objects we call components that you drag and drop onto your canvas, and you lay them out and you link them together, either linking workflow or data flow or both. You paint your code, imagine this, determines the Java code being generated under the hood. So it's important. And we're going to talk about some best practices along the way. One of the things I want to emphasize right off the bat is avoid big, monolithic jobs. Jobs that try and do everything. Not a good practice. Break it down into small units of work, right? And orchestrate them. You can have one umbrella job that calls a bunch of little jobs, and we'll see that too. But avoid those massive jobs that try and do everything all at once. Can you imagine how much Java is generating? Do you really think it's going to generate it that well, as opposed to breaking it into smaller chunks that do very specific things? It's going to do a much better job of generating that code. Now, quick overview. The architecture of Talend, there's many moving parts. A lot of them are optional. But it's, as a developer, it's important to understand what's available. Okay? So we have our clients. We have some web browser clients, like the TAC and the data quality portal and the data stewardship app and stuff like that. And we have the studio, and that's the heart of what we use as developers. We open up the studio, we build code. We talk to servers. In the TAC is the primary administration console that provides the connectivity to manage our source code control, our project management, and a variety of other things. And that sits on top of a database. There's actually a metadata layer to this, which is a database. And there's a whole slew of them, depending on what you have installed. Like the activity monitoring console, for example, has a database, which captures information about your jobs. And we'll see that too. Then we have repositories. And when I say repository, I'm usually talking about the source code control system, which is either SVN or Git, which is all linked in seamlessly. So you don't have to play with it outside of Talend. You just connect it up and open your job, start writing code, and when you save it, it takes care of seamlessly the integration into the back-end source code control system. Terminology is important. I'll kind of interchange database with the repository all the time. So forgive me for that, but understand that there is really a separation between when you're dealing with the database and when you're dealing with a repository. And we're going to talk about the project repository, which is really the combination of both. And you can see that depending on what you are using, you're going to interact with these modules differently. And some you may not ever touch or see. And that's okay. The point I'm making here is that as a developer and as a customer of Talend, you need to understand what these parts and pieces are. Take it seriously. Understand what they are, and you will be successful with Talend. I've seen too many times customers just jump in, install it, and start playing, and not thinking the bigger picture, the reference architecture. Really, what am I trying to do here? We also support continuous integration, continuous delivery with integration with tools like Jenkins, Bamboo. Automation is part of what we do now with the Maven architecture. This was a switch that occurred at about version 6. So most of our customers are probably version 6 today. But we still have our legacy customers out there on previous versions, 5.5, 5.3, and so forth. Yeah. Mm-hmm. Yeah, 80% of the market uses Jenkins. The rest, I'd say 20%, the next biggest share goes to Bamboo. But here's the interesting, well, here's the thing. We don't technically support them, right? These are third-party tools that integrate with us via our command line. So our command line technology is a command line-based technology that the Jenkins or Bamboo calls. So there is no specific thing or magic that we've done with our technology to support these technologies. They need to support Nexus, and they need to be able to have access to the command line in either Windows or Linux. Again, as long as it supports Nexus as the artifact repository and has access to the command line interface, either on Windows or Linux, it should work. And we have a couple of customers actually using Artifact Factory. Yeah. Okay. Now, there's a document out there. I would normally click on this link down here, but we have a new help.talend.com website, and I didn't update the link here. But I highly recommend you go there, type in SDLC best practices. There is a short document. It's probably about a 20-minute read. Highly recommend you read this document. This explains how to integrate with tools like Jenkins and Bamboo. It explains how to use the Nexus artifact repository, and it shows you that the best practice really is now to maintain your source code in a development environment only. Create and build your binary objects as artifacts, and publish and promote them through the process of going from dev to test, from test to UAT if you do that, and then further on into production. Okay? This is the document you should read. Okay, so look for the Software Development Lifecycle Best Practice Guide. And I could do a whole other 2-hour discussion just on that topic. So my point today is to point it out to you and tie it in with this next concept, development guidelines. The point I want to make here is we are going to figure out some kind of SDLC practice for our company, right? I'm a developer on a team. We need SDLC. How do we do that? Here's a list of what I call foundational precepts required to build out a good SDLC best practice. So I'm going to ask you guys, what's the most important precept on that list? Or the top 2? Come on, anybody. What do you think? Readability, consistency, maintainability, scalability, performance. We got a problem here. Functionality, whatever the... No, that's not on the list. Maybe I need to add that one. They're all important. That's the problem. It's so difficult to prioritize these. I couldn't do it either. I started out thinking, oh, this is easy. It's not. And these, I'm sure we could come up with more, but these I thought were the most important precepts. That's why I call them the foundational precepts that you need to balance all the time. So the real challenge is, how do you do that? And I think what we should do as developers is create a developer guidelines document. I don't like standards. Standards to me imply very rigid things. This is the way you do it and only this way, period. Well, but I didn't account for something. Or something in the business has changed. How do you deal with standards if they're not flexible? So I prefer, maybe this is just a semantic thing, I prefer to call them guidelines. And if you create a development guidelines document, you can allow for things to change. You actually develop this like you would your code. You put it into an agile flow and you adopt and adapt as you change, but there are some key things that you want to put in this document. Get the whole team together to talk about it. And we're going to see a couple of examples here in a minute. But once you define this document, and I have a handout which I'm going to have the PDF emailed to you guys. It's an outline of all the different kinds of things that you might want to consider putting in your development guidelines document. And then you might include a couple of other key documents. If you're putting in an API layer, you want to document that. If you better have a data dictionary there somewhere. That's the kind of stuff you must have to, as a team, develop code that will evolve and expand over time. And before I dive in, I love my Columbo. I'm dating myself, I know, but just one more thing. It's about good habits, instilling discipline. And that's a hard thing to do overnight. So what I recommend is start easy. Find something that the entire team is willing to do. I suggest label your components. It takes a couple of seconds. Every single component, come up with a formatting style. We're going to make sure we label our components, and you'll see how I do it in a few minutes. Let's everybody label our components. Boom. Now that's a discipline. Incrementally, over time, raise the bar. Make it harder and harder, yes, but make it easier and easier because it becomes habit. And that is going to, guess what? Make your code easier to read, easier to write, and easier to maintain. And by the way, I'll tell you what I think is the most important precept a little bit later on, because I've picked one. Okay, job design patterns and best practices. What are they? People always say, oh, well, that's the template or the skeleton or the jumpstart code that I create, that I own, and away we go. And yeah, I suppose that's true. But it's really more than that. Because these things are bound around a use case. Everybody's got different businesses to deal with, different data sets to deal with. So it's important to understand your use case along with these job design patterns, and you really want to then focus on code that is reusable. You want to build a lot of common reusable code, because not only will that shrink your footprint of how much code you have to maintain, it will make your code a little smarter. An example might be, let's say you have 10 different databases you want to process data against. They're same data. Do you write 10 jobs? Well, that's the easy way, easier to write, but it's hard to maintain. If one little thing changes, you have to go change 10 jobs. Or you make one job just a little bit smarter by passing in an argument, database number 1 through 10. And then in your code, you test, well, am I database number 1 through 10 and branch in your code? Makes that a little bit harder to write, but it's smarter code. And now you only have one job to maintain. That's what I'm after. Common reusable code module. It will strengthen your code base, condense the effort, and reduce that repetitive similar code. Nice thing about that is once everybody's doing it, anybody can read anybody else's jobs. And we're really nailing that easy to read, easy to write, easy to maintain concept. That's where you begin. And it's where best practices come in. So, are we ready to dive in? We're going to, his question is this about microservices, and does that play into this? And foundationally, yes. But microservices is a whole nother type or style of building jobs. So I would think of microservices as a use case, almost, in your job design patterns. Now, I'm not going to even touch on big data, or Spark, or microservices, or ESB, or any of this kind of stuff. They're extensions to this. So we're really going to deal with some of the basics first here. Let's lay the foundation. Then we can put up the walls and the roof and get fancy. So no, not yet, but this is a starting point. Microservices come later. There are a couple of good blogs out there on microservices, by the way. One written by one of the CSAs out of Germany. Good stuff. Okay. The first one targets that concept of painting code. How you lay out your canvas matters. Not so much in terms of the Java code being generated underneath, even though it can affect it. It really is more about the readability and the maintainability. Now, when I started, I came across all these examples of what I call the zigzag pattern. Bad design pattern. The reason is because it's very hard to maintain. If you need to put something in the middle there somewhere, You break your link, you put something in, what do? Read zigzag the whole thing? It's going to take you 20 minutes. That's wrong. I used to do that. I'm telling you, it's wrong. And then there's this other one I call the snake, which is just going everywhere, doing anything. That's wrong too. Again, very hard to read, hard to figure out what is this flow anyway, let alone maintain the bugger. So, what I like, what I found, and when I discovered this, again, I never looked back. Top to bottom, then left to right. Process flow, generally speaking, is top to bottom. Data flow, generally speaking, is left to right. Now, bend the rules a little bit where appropriate. On error handling, sometimes I go right to left. And in a couple of unique cases, I'll even do the process right to left, and we'll see an example of that. But I found that this job design pattern for laying out on your canvas is the most easy, maintainable, readable code that I can build. So that's what I recommend. Anybody have any other styles or flows that they'd like to share? Anybody disagree? You can, you know. It's okay. I don't want to be the only one making these suggestions. Number 2 goes to this concept I talked about earlier. Avoid these monolithic jobs. The way you do that is to compartmentalize your code. Units of work. What I want to suggest then is to make sure you understand how the parent-child orchestration works. Okay, we have this component called T-run job. This is how you can call another job. Why not break up your code into layers? And an example might be, let's say we need to process 20 million records, and we have to do it 3 different ways. So a 3-tiered architecture works, where your parent, your top-level parent, orchestrates deciding which of the 3 to run. The middle job figures out exactly specifics of how to run it, and the 3rd job does the heavy lifting and actually moves the data. Okay? You do that kind of thing with a T-run job. But the T-run job has some very specific things that you need to understand. So let's take a closer look. Can I zoom this sucker? It's hard to zoom on the trackball.
Sorry, did you say this is an example of how to do it right or how to do it wrong?
Oh, this is how to do it right. Okay, so the T-run job has 3 little checkboxes. Okay, you choose the job the child job you're going to run, and then you have these 3 checkboxes. So I want to discuss them briefly. Make sure you understand what they do, because they impact your code. The first one: use an independent process to run job. Okay, let's think about this for a minute. We have a parent job. He starts running. That means he's firing up a JVM, which means he's allocating memory and CPU resources to run that job. And I'm calling another job. Do I want that job to run in its own JVM? That checkbox determines whether or not it does it. And if you turn it on, then when it spins up, it will have its own JVM with its own memory, heap, and stack, its own core to process. Think of it as a thread, because that's kind of what it's doing. Whether that's on or off has dramatic impact to your job design. And we'll touch on this several times today. Yep. It will be running on the same thread within the same JVM as the parent. Yes. We're going to end with that topic. Parallelization is a very good one, and we're going to touch on that, I promise. But we need to understand the basics first. So this is a key to that, and we'll see when we get there. That's best practice number 16. Okay, the next one, die on child error. Okay, it is exactly what it implies. That means the parent will bail out of its JVM if the child returns an error. But what happens if the first checkbox is turned on? There's some implication there, right? That die on child error is only going to be appropriate to the VM that it's currently running in. So that child job, if it's running in its own separate JVM and it has a die on error, it will still return back to the parent and the parent will still run. Because it really didn't fail. It handles its own failure, killed its own VM, and popped back up to the parent, which is still running. So you need to be very aware of what you're telling your code to do, and whether or not that is turned on or not is key. There's only a few places where you can control bailing out of your code. We're going to talk about error handling too. Okay, that's something to be very aware of. And the third one, transmit whole context. Now you're all familiar, I think, with the concept of global variables, and you can create these context variables within a Talend job, and you can either have them built in or part of the repository, the project repository, which makes them reusable, and that's all good. But let's say you have 300 of them in your job. You call a child job, and the default is transmit whole context. That means it's copying all 300 variables. Now remember, Java is pass by value, not pass by reference. And that means that it's going to take a copy of all of those variables and use memory to have a copy and pass them down into the child job, which then manipulates the copy. And when it returns, the parent's copy is still what it was before you called the job. Okay? So it's important both from a good stewardship of memory utilization standpoint to turn that off. It is on by default. If you just have a few, fine. Turn that off. What happens is a little dialog box opens up and lets you select specifically which context variables you want to pass down into your child job. Now, if it's got the first box turned on and you're making a copy of these variables and you're passing them down, it's got its own JVM. Think about that. What's the impact to memory? Right? As opposed to if it's turned off and you're transmitting whole context within the same JVM, you're using more memory, you've got 2 copies of those variables in memory, and you've got to make sure you have enough memory to run the job. So be a good steward of these 3 checkboxes. Be aware of what you're doing. Any questions about those? We'll talk about them some more as we go through this. The last point on this orchestration, I realize that it's possible and there are no limits physically in Talend to prevent you from cascading or nesting many levels of parent-child jobs, on and on and on. So I even asked R&D, our VP of R&D last year, I said, okay, there's got to be some practical limit, right? How many levels of nesting can we go? His response, well, he would say 5 levels is pretty okay. We can go down 5 levels. I've gone deeper. It can work. But again, those other 3 checkboxes matter. But for all intents and purposes, in almost every application I've built with Talend, I've struggled with going further than 3 levels. I think 3 levels is pretty much going to be the most you'll ever need to do. But know that you can go deeper, but be very aware of your checkboxes: independent process, transmit whole context, and die on child error, because they're going to impact the communication of this orchestration. Okay. Now we've been talking about the T-run job, but there's also this concept or this piece of code called a joblet. Okay, so what's the difference between a joblet and a T-run job? Joblets are included methods. T-run jobs are called. Okay, so you can create a joblet, and it's shown right down here in the log processing, and we're going to look at that joblet in particular because it's unique. But now I've got a joblet. This is a piece of code that I've created elsewhere in my project repository that I can reuse. And because it's a joblet, every place I put it inside my job, it's going to use that code. It's included in what's generated. In fact, what's generated is a class, a Java class with its methods. So even if you reuse it 20 times, it's only going to create the class once, and it will reference it every time it's needed. As opposed to the T-run job, which is actually calling a completely separately built job. So it has its own jar file. Okay? That's the difference between these two things. Most of the time you're going to call T-run job and call jobs. But wherever you can create joblets, that's a big win, because joblets can be very powerful. I advise keeping them very specific to units of work. Just do this thing. And we're going to see what the log processor does here a little bit later. Okay? Good news is they both promote reusability, which is one of our goals. That's what we want to achieve. So try and use joblets where you can. Otherwise, T-run job is the way to go. It's also important to understand the entry and exit points to a job. Coming in and going out. We have two components. In fact, I'm going to open up this guy. Two specialized components called T pre-job and T post-job. Okay, see if I can zoom in here a little bit. That's good. Okay, and here's where I even break my layout rule a little bit, because the T pre-job and post-job are unique. They are a nice way of orchestrating within a job your entry and exit of the job. Okay, so I like to suggest the start job, that's my label, on the pre is a way of initializing your job. In my use case here, I have to go check to see if a directory exists. And if it does, I'm good. So I have the good path, the happy path, on subjob OK, file list success. Otherwise, open failed. Those other two components, T warn and T die, are also ways of managing entry and exit points, specifically exit points and specifically the T die component. Because that's another place where you can turn on that checkbox to exit your JVM immediately. Okay? So it's a controlling component. I might, for example, instead open my database connections on the initialization flow. And if I can't get a database connection, exit out by turning on the exit JVM immediately. Why bother continuing if I don't have a database connection? I'm just going to generate errors if I continue processing. The post job, that's where you wrap things up. Closing database connections. Putting up some messages. Right? That's all I'm doing with my wrap-up job. That's a T-Java component. I'm just putting up some messaging. Job began, job finished. That's great information in logging when you have orchestration going on, because you know whether or not it actually successfully called the job in your log, just by a simple message. I came in, I left. The body of the job is the call to the child job, and then down below, we have the joblet. I'm going to show them all. Nobody's asking me, what do those green backgrounds mean? You've seen them. Did anybody notice? There's 4 components that have a green background. Anybody want to guess, or maybe they know, what that means in a Talend job? Say first? Success? No. Success. What was the other one? Signifies a section? Bingo. Starting point. That green background means I will start executing this component first. Oh, wait a minute, there's 4 of them. Does that mean all 4 of them start at once? Almost. Because pre-job and post-job are specialized components. They will start first and finish last. Okay, so that's like a try-catch block, and the post-job is the finally. When it's all said and done, let's wrap up. It's green because it starts off and says, okay, I'm ready to execute as soon as I'm told to, which is when the rest of the job is finished. The start job will begin and everything under it will complete before going on to the call job, which is really the starting point of your job. But the log processor is also green. That's a joblet. And that is my error handler. And there's a reason why it's green, and we're going to see that, I think, on the next thing. So, yes? Another question?
No, no, I just need to say it.
But there was a question, yes. Sure.
How many, do you have like a good recommendation of like avoiding those sub jobs, so each sub job should have a joblet or a separate joblet if you won't you want that, for example?
Right. Well, joblets, of course, will get included in your code, so use them as much as you can. But you're not going to find many really good uses for that. An error handler is a good one, and we're going to look at that one specifically. But sub-jobs, there's different ways to orchestrate them. And when we get to the discussion about parallelization, we're going to talk about a higher level way of orchestrating. You can either do it with a umbrella job, and yeah, it can call as many subs as it wants. One job can call 20 or 30, 100 T-run jobs with that layer. But I question that. Should I really be doing this, or is there another way to do that? And the execution plan, and we're going to look at that. Yeah.
So just to clarify, is a channel job or just jobs in general we're talking about?
This is just jobs in general we're talking about.
I can't read it exactly, so that top part is the free, the middle part is kind of the main job,
Yes.
and then that, the job is at the bottom, obviously, and then
Is that better? So yeah, so what will happen, this job starts up, first thing it's going to do is run the pre-job. But you know what? Actually what's going to happen first is the log processor, and we'll see that in a minute. So let me explain that on the next slide. But forgetting this for a minute, the way this job will flow is run the pre-job code first, it'll then run the body of the job, and then when it's finished, it will run the post-job. The post-job will always run last. Okay, so this is a great way of designing your flow in your job, every job. In fact, I don't have any argument for not using pre-job and post-job. Always use them, is my recommendation, within your jobs. Not the same with joblets. Yeah, yeah. It's a great way of writing nice, clean entry and exit flows within your job. We understand now about the entry and exit points, the green backgrounds, and the exit immediately. And of course, I put T-warn at the end of my post job, which doesn't control the exit of the JVM, but because it's the last thing in the job, it will exit the JVM, and it gives me a way of posting up a message about the fact that it finished running the job. Okay, let's dive a little deeper. Probably the most important thing you can do is include error handling in your code. I would have preferred to make this best practice number 1, but we had to figure out how to manage our canvas first. Error handling, if you don't do it in your code, you're just biting yourself in the butt, right? You're going to trip somewhere downstream. The sooner you adopt and adapt some kind of handling mechanism, the better. So this is the joblet that we've been noticing on the example jobs. So let's look at it. This is a very generic solution. I actually had a customer implement it in production. I'm going, whoa, no, this is just a sample. But let's look at what it's doing. The first component is a log catcher. Oh shoot, I can't quite see it. Let me move this up a little bit. Oh shoot. There it is. Okay, it's a log catcher component. So it's a listener. Its job is to listen for exceptions. I control what exceptions it's looking for. any Java exception, a T-die, which is an exception that you throw, or a T-warn, which is also an exception you throw. And remember, an exception doesn't necessarily mean an error. There's 5 levels of priority: debug, info, warning, error, and fatal. You select which level of priority you want to throw as your exception, and this log catcher will catch it. It has a whole schema attached to it, which includes important information about the PID, the thread it was, the error code, the message, whatever you want, and I process it through a T-map and fan it out and say, depending on the level of priority, I might want to handle this differently. In my case, I'm doing a real simple thing, which is just logging it to a CSV file. What you do with this is up to you, but this gives you a platform, a simple, single place of handling and managing all your errors across all your jobs. Rather than write an error handler for every job, I write one and include it as a joblet. Okay? What you do with it after that, you're kind of depends on your particular use case. I had one customer, as I said, took this verbatim, dropped it into every job, and unfortunately, when getting to a file, it doesn't flush the buffer immediately, and so he was getting deadlocks on file write IOs, right? Because in the file name, he didn't account for the fact that maybe I'm going to have different jobs running on the same thread or different threads at the same time, and you have to account for that. Right? So we made it a little bit smarter by putting directory structure into the file name path, including the job name for each joblet. So the joblet is still generic, but he had to make it a little smarter to incorporate a directory naming convention that could handle multiple threads. So it was writing to different logs simultaneously, as opposed to trying to all write to the same file, and it just didn't work. But the point is, have an error handler. This is an example of how to do it, and what you do with it from there is up to you. But by itself, it isn't enough. What you also need is a clearly defined set of return codes. So I have an KB article out there, Conventions for Return Codes. Okay? And it has to do with those T-die and T-warn components specifically, right? And you can see here on the T-die component, we have 3 attributes in the Basic Settings tab: a message, an error code, and a priority. A priority of those levels that we just saw I was fanning out in the joblet. The message is entirely up to you. I don't know if you want to constantly log the end is near in your DevOps log. That might confuse people. So come up with a convention for structure and meaning that works for you in a message, and the error code, which I think of, it's really a return code because it's not always an error. If it's always 4, is that helpful? No. So what do we do? Well, looking through this article, we also see on the advanced settings where we can control the exit of the JVM. We talked about that. The priorities, there they are. Okay, great. Move on, Dale. What's up? Oh, here we go. Come up with a return code scheme. And this is just a suggestion, an example. It works for me. I incorporated this several years back. I prepare a return code that is made up of 3 values. The first value, it maps to the priority. Info, warning, error, fatal. 1 through 5. 6 rather. System tells me where the error has occurred, and type of exception tells me what has occurred. So now I can create a return code that has some meaning. And let's look at some examples. Okay, so I've mapped the priority levels, 3, 4, 5, and 6. I don't care about 1 and 2 because that's trace and debug, but you can add them. System tells me where the error has occurred, file system, database, whatever. And the type of exception, and remember they're not always errors, connection, locate, check, open, close, read, write, create, all that good stuff. You come up with whatever you need. But then what you come up with are return codes that have meaning that you can now programmatically control within your code. So a 3605 means that I successfully opened a file. whereas a 5701 means I have invalid login credentials to my database. This is important information, that because you've devised a return code that you can trap using these components, you can actually test within your code for these errors, these exceptions, and code appropriately around them, right? Rather than leaving it all up to DevOps teams, you might want to think about using some kind of return code scheme. And again, this is just a suggestion. Come up with whatever you want, but come up with something and incorporate it into some kind of, shoot, I went too far. Some kind of error handler like this, and you now have the tools you need to handle errors within your code. Now, one last thing to mention here, Log4j. We implemented Log4j on every component starting in version 6. So you will have that defaulted as on. You can control that within the project settings if you want to turn it off, or you can specifically, with the Log4j appenders, decide how you want to format your Log4j information. So think of it this way. Log4j is your technical log. The tDie, twarn are your operational log. So you can now separate these two things. The one in terms of the operational, you can control within your code. So you can programmatically decide what happens next based on a return code scheme with a joblet like this and go from there. Yes?
So today, for example, in Java, you have SLS, basically, facade, and you can,
Yeah.
as long as you follow that path, you could poke it through whatever
Right.
looking engine you want, based on the needs.
Today, we are just integrated supporting Log4j, the SDLC stack. Okay, so if something else were of value like that, then my recommendation is to put in a request for a feature enhancement. But so today, the answer is no. Log4j is the most common, widely used framework, and so we start there and expand out. So it's not that we won't ever do it, but when we hear from customers, we take a look and we listen. Okay, got a couple more here, and these all tie in. That's all part of a story, right? Again, another thing that's really tricky is when you link components together. We have these triggers. On component okay versus on subjob okay. There is a difference. And it's important to understand that difference because they can be a little confusing. So let's examine what they really mean. Okay, these triggers affect not just the Java code being generated, but the actual flow control. I'm going to make this just a little bigger if I can. That's about right. So let's walk through this on my pre-job. And you see I kind of broke my top-down, left-to-right rules, but I'm still kind of following them. My pre-job, I do the left to right because it's just easier to read. I'm opening two database connections, and if either one of them fail with the on-component error, I have a tDie, which has the checkbox turned on, exit JVM immediately. So the only way this job is going to continue onto the body, which is this process data subjob, it has to get me two clean database connections. Okay? Otherwise, I throw an error, and my joblet handles it. And then, at the end, I close my database connections. So now I got a nice entry and exit in my job design. Cool. The job itself is reading data from a MySQL database. Probably, I think this sample reads 100 rows. It filters out 10 rows and writes those 10 records to another MySQL table. But look at this. We're managing the flow through a variety of triggers. The first trigger on the read on subjob OK, that message box 1 will only execute after the entire subjob completes successfully. That means it has to finish reading 100 rows, finish filtering out the 10 and finish writing those 10 records completely and successfully for that message box to pop up. Executed on subjob error will get triggered. This is nice, clean error handling at the top level. Okay, is reading 100 rows, is going to filter those rows. On component OK is triggered, but now let's figure out, is it going to trigger after 100 rows or after 10 rows? Who wants to take a stab at that one? Message box 2. When will that pop up? I can see you thinking. After each row. That's a common misconception. I thought so too, but no. Say that louder. After the component's done is the correct answer, but what does that really mean? The filter row component requires all 100 rows in order to filter 10. So that component will not be finished until it's processed 100 rows. So T message box 2 will only trigger if it can process a filter of 100 rows. The fact that it's pushing 10 rows downstream is irrelevant. That's what it's filtering. Okay, so now on the T MySQL output, where I'm saving the rows, how many times is message box 4 going to trigger? I thought I heard it. 10 times. Because that component is complete when it reads, or rather, when it writes a record. It's going to write 10 records. Now, that's only if auto commit is on, right? Because it's going to auto commit after each row. So it's very tricky to understand exactly what's going on here. Now, I've also got an if statement trigger off of the filter where I'm testing my return code. So if, and this is cool, error code is greater than 5,000, I know I have an error I have to handle. So I can create an expression block in my code and trigger based on my return code settings that I had. Very useful when you've got a T run job here. Not so much on the T filter example, but I wanted to show that you can trigger on a run if just as easily. Maybe it's because some flag is set, right? Debug is on, so I want extra information. On the final end of this, on component error will trigger if any of those 10 rows fail, but it will keep running. And then you can also catch your rejects. So if, let's say one of those rows violates a constraint like a primary key violation, you can catch those records and save them off and keep a log of all the records that it failed to process. So my intent of this example was to kind of show all of the different kinds of triggers and examples of triggers that can occur within your job. This is going to handle the errors, control the flow, and what you do with it. All right. Any questions about this? Because this is pretty key. All right. I see a lot of nodding heads. I like that. All right. And the thing that I think ties this all together is something we don't actually put in our documentation. This is one of my own discoveries. Once I started doing the top to bottom, left to right, I discovered something else. What am I really doing in a job? I'm processing a loop. Either I'm reading a file list or I'm selecting records out of a database. I'm processing a loop. And when you identify where your loop is, you can build your job on that. That should be your sub-job. So let's look at this. Very similar kind of thing, right? You can see my pre-job is opening my database connections. I even have a T-Java that's specifically setting up my connections. But I have a main loop here. Come on, why aren't you? Oh, I need to go that way. I'm reading an Excel file. I'm processing rows I find in the Excel file. For each row, I have to parse them. Once they're parsed, I remove nulls and save it to a database. and I'm handling my rejects. Great. You can see all the error handling in there, but that is my main loop. And here's my recommendation. Find your loop, and at the very least, put your error handling there. Notice I'm not putting a T-warn or T-die on every component, because you really don't need to do that, right? That's a little bit over the top. So if you've got your loop identified and you're building your job around the loop, that's where you want to have minimal error handling. So as you can see, when I drop down for every row I'm parsing, I have to do some extra work. I've identified a secondary loop, where again, I'm handling minimal error or exception control. Once each row is parsed, it goes back up to the primary loop and away it goes. You can see how I'm controlling that in this example. So these first 7 best practices, I think, give you the foundation for designing good jobs, no matter what you're doing. These are the kinds of things you want to look for. Okay?
What are you saying with this one? Just identify your loops, where they are.
Yes. Construct your job around the loop, which is your process. It's either a file list, whatever you're doing, you're probably doing some kind of a loop. 99 times out of 100. Okay, so look for that, identify that, build your main flow based on that, and don't worry about secondary or trinary loops. You can do that. Nest it as far as you have to. But again, keep in mind, don't create monolithic jobs. And it could easily be that the secondary loop calls a T-run job. It could be running on an independent process. You got some power here now. I can see you all thinking, in my use case, I'm going to use this here for that and this for that. That's the idea. Yes?
You said about the job, and excuse me for using that example, but I'm system programmer in my background.
Sure, no problem.
In Linux, you have, for example, in POSIX, you have signal handlers, right? And if we get this signal, we do this, we close database connection. If we get this signal, we close parameters.
Right.
Is there any way for me to write my jobs in a way that it will always do cleanup?
So can the job be written in such a way that it always does cleanup?
I mean, so that it will always invoke that joblet.
That joblet, it's in the the joblet itself is an exception handler. Because it has the log catcher component in it, it's listening all the time.
So the log catcher is the right way to do it.
Yes.
That's the key.
Yes, that's the key. To do what you're talking about, that is the way to do it. So an error handler needs a log catcher, hands down. There's really no other way.
Always there you could add, for example, closing a database connection.
Sure. You could. I wouldn't handle that detail in the log catcher code, but I would set a return code so that when you come out of the finally, after your job is done, test for a specific error that says, hey, because of this error, I need to do this. Okay? And you can either do that in the body of your code or do it in your post job. Right? So yeah, absolutely. You're thinking the right way. Okay? Other questions on this?
So you are handling the rejects there in hand, right? So is the reject option comes by default for each and every component, or do we need to set up configuration?
The reject option is available on all the database output components.
Let's say you find components. Let's say there is a default input deleted.
There is the trick is to look at the component and look at what triggers are available. Not every trigger is available for every component. In fact, you might even notice, I should have said, not all components have a subjob OK trigger, right? And all of them have component OK. In fact, a great example, I had a customer, he was struggling because he wrote this, it was a rather monolithic job. He was doing lots of things in this one job, but he connected everything with an on component OK. And he said he had to do that because the on subjob OK wouldn't connect. And there's a reason for that. If you can't connect it with an on subjob OK, that doesn't mean you should just automatically use on component OK, because as you just learned, that on component OK can trigger differently. In fact, that filter won't trigger until the end of the process, but the output triggers every time it processes. So knowing your components and what they're doing is going to affect component OK outcome. So it's kind of like the difference between synchronous and asynchronous code process. So you can get yourself into trouble. And what he was doing was getting himself into trouble. Everything was on component OK, and he had a subjob with a loop that was processing. He didn't want the next subjob to fire until it was finished, but no, he was firing it on every row. So it was firing 1,000 times. Pretty soon he got himself into a memory thrashing algorithm with a 100% CPU spike, and the job never completed. When we redesigned it to use on subjob OK, and yeah, he had to rethink some things, that job ran in 6 minutes. So very important to understand how those things work. So rejects are really found mostly on the output of data components, right? I think you can control a reject out of a T map as well.
I have seen some of the input components. So let's say if I
Some of them do. Yeah, there's over 1,000 components, so I can't give you a specific list. But yeah, where you find the reject, that you can do what we show there.
one more question on the joblets.
Yeah.
So can we pass parent context parameters to the joblet?
You don't need to. So the question is, can you pass context variables to a joblet? Well, the joblet is included in the job. So it's going to see and have access to those same context variables. Now, when you declare and define the joblet, you have to declare those same variables. Let's say it needs 3 variables, a file name, a file path, and an error code. Right? In your main job, you define those 3 variables and you control and access them. And the joblet only needs those 3 defined, but because they're defined, they will share the same heap because they're running in the same overarching Java class. Okay? You don't call it a joblet. That's how you do it. You don't. You call a T-run job, joblets are included. So they become embedded in your Java code being generated. Okay? Super. Yes? Correct. Right. T Java _1. Yeah. Right. Yeah. Right.
So in this case, how can I, code saying like, I want to capture that component's number. The parents say as a global variable, I want to feed it into a database or something.
Right.
How can I safely give a name to it which doesn't change? What if I didn't put the joblet yet, but I developed the job? This is the first time I'm using a different Java component, and you put a Java 1 to it.
Right.
What happens when I drag in a joblet which also has a Java 1 component?
So does everybody understand the question? It's like I have a joblet, okay, and I want to capture some meaningful values that might be generated by the joblet, like a record count. Okay, many components have these system variables available after the component is executed, and you can easily capture that variable and pass it to a database or a log. Well, the answer really is a joblet is not a component. But components within the job have the same capabilities and characteristics of a component outside the joblet. So it has those same variables, but what you're going to need to do is take that at runtime and save it into another context variable. Right? So that context variable is defined within the overarching job and the joblet so that you can set the value in the joblet and then it's available to you in the job.
So I have to assign to the context variable the value of that component, but the
You have to assign it within the joblet. So within the joblet, it has its object name. And so within the joblet, just after, you would have a tjava component that saves its value in your context variable. That context variable is available outside of the joblet. So it's a little bit of a handshake, a two-step. The way to think of it is a function. It's a method. It's a class, right, of its own that supports its purpose. So yeah, I think of it like a method or a function. Well, every job you generate and build becomes a jar file, but joblets do not become jar files. Jobs become jar files. So when you have two jobs and you call one from the other, you're basically, the Java code being generated is the code necessary to call and execute another jar file, where the joblet is embedded in the first jar file being generated and built. Good questions. Okay? Awesome. We're only halfway through. Someone's got to keep track of time for me too, Nick. But they seem to be liking this. Okay, so I talked at the top here how important SDLC is, so I make it a best practice, right? I don't know if you guys, not my favorite show, but I like watching it. It's fun. This guy, Marcus Lemonis, he goes in and he fixes a broken company, or tries to. But he looks for three things: people, process, and product. So in my view, we just change out product with technology and we've got the same metaphor. So it's very important to have an SDLC incorporated into your team effort. That then is in itself a best practice. Don't not do it. Okay, it's very important. Again, I'm pointing out that same best practices guide. I recommend you read it. There's even a couple of YouTube videos out there. There's some new blogs on continuous integration from the CSA team. Great stuff. And if you haven't already been made aware, for customers, the CSA team are doing expert sessions, webinars, where we're talking about specific content. And if you aren't able to attend, you can register and you'll get the recording later. If you've missed one, then you can still register and get the recording. Okay? That's for customers. All right, so let's start jumping around a little bit. Number 9 talks about workspaces. So when you have the studio on your laptop, desktop, whatever, it is going to need a workspace, a local location on your disk where your copy of the source code is placed. And when you save your work, it saves your workspace and then synchronizes with the SDLC in the back end. Okay? Where you put that workspace is important. Okay? By default, up until just recently, that workspace was placed inside the directory where you install the Talend software. And I have never liked defaults by software companies, right? Do you change the password on your database installation for Oracle or Microsoft? Yes, that's the first thing you do. Same kind of thing here. First thing you want to do is figure out a common place where all your developers will use a directory naming structure. I like to incorporate the Talend number. So I have a tree called development Talend v641/workspace on a different drive if possible. But at least somewhere other than your Talend installation directory. And as of 6.3, we now, during the install, prompt you, where would you like your workspace? So we're getting a little smarter about that. So make sure you change the default to something your team can agree on, and then everybody should adopt that same pathing mechanism. That's why everybody knows where your workspaces are. That's an easy one.
Is it in the preferences area if you want to change it?
When you create your connection to your project, you can specify that. By setting it now at installation time, that gets set to a default that you control. But then you might have multiple workspaces. I like aligning them by version. That means I can have 2 versions of Talend Studio, 6.3 and 6.4, pointing to different workspaces. Don't ever point them to the same workspace. Okay, how many of you guys reference projects? 2, 3. When I started out, I swear, I kicked myself. For multiple years, I complained. How come I don't have a way of taking this reusable code and sharing it across my projects? I was copying and pasting like crazy. Hard to maintain, silly me. This has been available for a long time. It's called a reference project. And what you do in the TAC, when you create a project, you have a little checkbox over there on the right. Your right, my left. Called reference. When you turn that on, that makes this project a reference project. It works like any other project. You can create objects, jobs, joblets, variables, everything within that project. But now it becomes shareable across all your other projects. Notice I kind of gave it a name that makes sense, right? Common code. This is where I'm going to put all of my reusable code. And that's why I even put that in my description. Because let's say I want to create another project, my CSA Tools project. I go down to the Project References tab and I create a link by, I wish this had a laser too, right over here. You just click that link and all of the objects defined in the reference project become available to you, the developer, in the CSA Tools project as read-only objects. Okay? So now there is a place to put your common code. Now, the idea here is to just have one reference project. And I've had a couple of interesting conversations with some customers who have taken a slightly different tact. One who had 8 different reference projects. And his argument was, well, I have 8 different development teams. I want to have them have their own reference project. Well, that kind of makes sense. But then I asked, well, don't any of them share any code whatsoever? Well, yeah, they do. So what do you do then? Well, what we wound up with was we created a 9th reference project that had an umbrella to all the other 8. And you can nest reference projects, but I recommend doing that very carefully. Right? It doesn't really impact your code generation, but it becomes a little bit harder to manage from a project coding management standpoint. Now, I had another customer. He had 20 reference projects and one non-reference project referencing them all. I go, well, wait a minute. That seems weird. That's backwards. Oh, no, this is great. I have one project I can open up and have access to everything. And down at the bottom, you may have noticed in the bottom right of the job, you can generate documentation. You generate the wiki of your entire project. Well, what he did was he was using this one project with all the references to be able to generate a wiki on everything. That's not the purpose of a reference project. He didn't get any value out of the common code concept, but I couldn't argue with that. It worked. It did what he wanted to do. So there you go. Yeah. Yeah, you don't want to do anything outside of the studio and TAC. So my recommendation is to identify at least one member on each team responsible for the promotion and publishing into a reference project. Have a gateway person or team that manages. So if I'm a developer, I'm creating a new object, I'm going, wait, this is great reusable code. Let me hand it off to that team who vets it and puts it into the reference project and manages it. So it's a managing kind of thing that you have to incorporate into your SDLC. Okay? We provide the capability for you to do it, but as a team or a bunch of teams, you have to come up with your own mechanism and philosophy and practice around doing that. But I recommend that you create that practice and get everybody to do the same way. It's an extra level of work, but there's value in that work. And it's a whole hell of a lot better than cutting and pasting like I did for 5 years. But there was only one of me, so it didn't hurt that bad. But yeah, for big teams and cross-functional teams, and some teams have access to some objects that other teams should not. So you have to manage that. Okay, I want to be sensitive to time here. So let's see if we can't press on. Again, another one of those best practices that I wish were way, way earlier in the discussion. Object naming conventions. Yeah, it was somebody like Shakespeare who came up with that. A rose by any other name is still a rose. Well, it wasn't exactly his quote, but to me, establishing a naming convention must be done at the beginning, if you can. It's never too late, but if you don't come up with a naming convention until you're well down the road, then you have a decision to make. Do you go back and refactor your code? Depends how much. Or do you, from this date forward, use the naming convention? And naming conventions apply to everything. Directories, file names, object names, variable names, everything. And this link, Conventions for Object Naming, you can go find in our knowledge base, has a whole bunch of examples. I mean, for one that I like to talk about is when I have jobs that dump out data files into a CSV. That's something you should have a naming convention on. So I like using a naming convention that has a year, month, date format, underscore, table name, dot, text, or CSV, or DMP, or whatever it is. That way I can always sort and process files by the date they were dumped. Right? So be creative. As a team, agree on what your conventions are going to be. The sooner you incorporate them into your developer guidelines document that I talked about at the beginning, the better. Something that really should happen first. Now in the studio, off to the left panel is this thing called the project repository. Remember I said earlier on, this is really the combination of your SVN repository and the metadata stored in the TAC. Okay, when we save a project, we're not just saving our code, we're saving everything in the project repository, which includes the code. In fact, there's this section here called metadata. That metadata is where you can define all of your structures that you need within your code. Things like database connections. So here's an idea. Create a database connection, convert it into a context group, and save them both into a reference project. That way you only have to define that once. Then everybody can use that database connection. Those context groups should be probably aligned by dev, test, prod. That's the best practice. You don't have to do it that way, but that's the best practice. Now down here, you can see on the bottom left, I have an example context group. Oh shoot, I missed it. Try again, bingo.
Demonstrate like when you have the different context groups, you have specify like how you got it configured so that you automatically switch between your phone.
So I can demonstrate that after, if you like, because it takes a couple of steps to do that. I have to fire the studio. But when you create a database connection, right, you type in your connection string, and you can convert or export as a context. Creates it as a group for you. Then you can go into that context and create the dev, test, prod. By default, there's a context called default. I eliminate that one. I delete it. But I create dev, test, prod instead. And then I can, when I go back to my database connection and I want to test the connection, it will prompt which environment you want to test the connection to. It's defaulting to dev because you said that was the default. You click test, and it uses those connection string values. Yes, right. Another thing I do is I create a context group of all of my really most commonly used variables that everybody needs. Things like string lineout, string max date, min date, etc. I have one I add called sysenv type, which is like a constant. And I give it the value of its context group. I have 5 here. I have a sandbox and a UAT. So sandbox, dev, test, UAT, prod. So inside my code, I can test at runtime which environment I'm currently running in. That's an easy trick that will allow you programmability to write your code to behave differently depending on whether it's running in dev or prod. In dev, you might want to add extra debugging, or you might want to limit your SQL to only return 100 rows instead of 1,000,000, because you can iterate through your develop and test cycle much faster without having to modify your code. You can test at runtime which environment you're on. Real simple trick, just do that, add one and use it. In prod, of course, you skip all that. So you do a run if vtype equals dev or not. Lots of things you can do like that. Let's see, click the wrong one. Okay. 13, ooh, the dreaded 13. And it has to be version control, doesn't it? Right. Now, we sell a subscription-based product, but we also have an open source studio that you can download and use for free and actually build real code with. Both versions, if you right-click on a job, you go into the properties, you have this wonderful button called M for major and little m for minor. And wow, if you click that, your version number changes. That's pretty cool, right? Well, guess what? That is for the Open Studio users only. Because they're a single user, they need version control. That is not for all of you that have the subscription-based product, because you're tied into a source code control system that does that for you. You manage with branching and tagging using SVN or Git, please, because this is what happens. Every time you click that M button, either one, a complete copy of your job gets created in your workspace. And if you're synchronizing with your SVN, every time you open or close your studio, you have to synchronize every copy. I had a customer who said, it's taking 15 minutes to open the studio. What's going on? I said, well, I don't know. Let's take a look. He sent me his export. I loaded it up. It took me 15 minutes to open his project. All right, well, I looked a little deeper. 450 jobs, so that was a lot, but it still shouldn't have taken 15 minutes. But then I noticed job 20.2, 19.8, copy of 3.7. I'm going, shit. Ooh, I probably shouldn't say that. Darn. I looked under the hood, and there was 9,500 copies of those files in his workspace. Of course it's going to take 15 minutes. So I exported his highest level jobs. So I got 450 copies. I recreated his project, and guess what? It opened in 3.5 minutes. So those buttons are not for you unless you're Open Studio single user, because you got to have version control too. And for a single user, you're not synchronizing anything. So not so bad. It's great that we support both, but I wish this was something that was obvious, but it's not. So very important. Best practice, use the source code control system for all your branching and tagging. That is the right way to do it. Tag every version and only branch when you need a copy to maintain. Okay, so your true release candidates, you branch. Otherwise, you just tag it. All right? I mentioned here, since version 6, we've supported Git. Okay, how many in the room are using Git as opposed to SVN? Okay, we added Git because we had a lot of customers asking for it. And as we progress, we're adding more and more capabilities and features to Git. In version 6.2, we supported the diff merge capability, which is not supported in SVN, but it's at the job level. So if you have your sandbox, you're working on a job, and you check it into Git, it can tell you, well, somebody else has modified that job. Here, I'll graphically present both versions. You decide which one survives. You click on it, and it saves that version. Now in 6.3, we've added the ability to do that diff merge at the component level. So you can actually stitch the two jobs together and have survivorship at the component level. It takes a little bit of work. So you want some best practices on your team to avoid that, but when you have that need, you can do that. Not supported in SVN, very important. Okay, we're getting there. just a few more. Yes.
So basically, how do you manage, so let's say you have, you want to be able to allow developers to work on different jobs. So one way to do it is that having, I'm talking about different jobs, having one repository, one repository.
Right.
But that
Not the right, yeah. Best practice, even with Git, is to create your branching and tagging along the lines of your project, not your environment, right? You can tag versions, but you're only going to maintain your source code within dev. So you publish an object, you build the object, and you put it into Nexus Artifact Repository. You create snapshots and releases, and you publish and promote those forward. So your repository should be project-based.
I think about what you've done for each job, we create a repository.
Yeah. You don't need to do that. It's extra work, and it kind of gets in the way. I've run across a few customers doing it that way, and I'd recommend bringing it all back up into the one big project. Okay, you can still manage things. If you want, create folders within your project. If you want that, I understand the desire for organizing.
So it's like in 6.3, you could have a lot on the job done, lock the whole repository.
You only lock the job you have open for edit anyway. You don't lock the whole project by opening the project. So 20 developers can be working on 20 different jobs at the same time within the same project. No problem. Those developers who are open for edit, the other programmers can still open for read, but they can't edit it because one guy's got it locked for edit. And there's an auto and manual locking mechanism. So we can talk about that some more offline. Yep. Okay, memory management is something of great importance, but really we have very little direct control over memory management. How we control it is in our job designs. And I've alluded to some of them already. And you can see my list here. Here are the questions you want to ask. Okay, how many millions of rows am I processing? Or how many columns am I processing? Am I processing 20 or 700? You know, this affects how much memory is going to be used. How many TMAP lookups am I doing? I have a TMAP with data flow into it, but 20 lookups. Okay, that's going to need more memory, right? How many child jobs am I calling? How many levels of nesting? Am I using independent subjob? That all affects memory. And whether it's in the same JVM or you're spinning up multiple JVMs, here's the thing. They're running on a job server somewhere. That job server has to have the physical memory to execute your job. And it's probably also going to be running other jobs at the same time. So it's very interesting that the impact of memory management can have, and you have so little control over it, other than through job design, with the exception of on the Run tab, you can go to the advanced settings, and you can actually set the JVM settings. Minimum allocated and maximum to allocate with the XMS and XMX setting. We had a customer who was setting the XMS to 2 gigs and the XMX was 4. They calculated their almost 800 jobs to require 75 job servers to run, when in fact most of the jobs only needed 512K. Only a few of them needed 2 gig. So we helped them understand how to size these things properly, and suddenly they only needed 20 job servers. Now at $3,000 a month times 50 some odd job servers, that saved them millions of dollars just by setting that value correctly. That value can be overridden. So the developer sets it, what he thinks it's going to need, and you also have a new tab here called Memory Run. So the developer can run the job and actually see how much memory it needs, so he can set that value appropriately. The DevOps guy running it in the TAC can override it if necessary. Maybe suddenly the table that had 10 million rows now has 100 million rows, so it needs more memory. Really? You have to go back to the developer and change it? No. You can change it right there on the TAC. And then one of the other things, we're going to talk about parallelization. Yes, that impacts memory, as you might imagine. So we're going to look at that in a minute. Okay? So keep in mind, in the back of your mind all the time, how much memory am I asking the system to consume? That's about the best you can do. And factor that into your job design. Whether you're doing parent-child calls, whether you're setting those values, whether you're copying 300 variables in your transfer or just the ones you need. See why these things are important? All right. Not last, but probably the least, and pretty obvious, is dynamic SQL syntax. This isn't dynamic SQL like you're used to in Oracle or Server. This is constructing SQL syntax dynamically within your code. Pretty cool. It's really simple. Have some context variables, and you can see my naming convention makes it very clear what I'm building here. My columns, my where clause, my order by. I even had the SQL limits. Remember, you could test for if I'm running in dev, I can assign a value to the SQL limits, so I can only get the top 100 rows, as opposed to always having to process 1 billion rows, because that's what my data source is. Construct your code, your SQL syntax, dynamically in a T-Java component, and then place that into your SQL input component. Okay? So yes, you can do that. It's a pretty nifty trick. That way it's going to determine at runtime what that syntax is going to be. Maybe the runtime determines exactly what table name is going to be used because of some business logic that you pre-processed. So this is the way you would do that. Any questions on that one? Pretty straightforward. Okay, now we get to the fun part. Last but not least, parallelization. I have to say that 20 times, otherwise I call it paralyzed. And your code will be if you don't do it right. Okay, there's lots of ways to do parallelization in Talend. And we have to do it the right way, or we can get ourselves in real trouble real quick. So use it sparingly, use it with common sense, and you'll be just fine. You will be able to create highly efficient code if you do it right. Okay? When we think about that nesting of parent-child jobs where we wanted to process 20 million rows down at the child level, third level, what if we could parallelize that 20 million rows into 5 threads? Isn't that going to shorten the amount of time it takes to process? Yes, it will. So how do we do that? Talend has what I call a parallelization, see? I trip over myself every time. Parallelization option stack. And now we're going to come back to one of your earlier questions, sir. And I forget, what was your name again?
Call me Jason.
Jason.
I won't have you pronounce my name.
Okay, Jason, this one's for you. The parallelization option stack starts in the TAC at what's called an execution plan. Lots of schedulers have this capability. So does the TAC. So when you write a job and then you have it deployed through the TAC, you create in the job conductor something that's called a task, which is a wrapper around that job. And you define some things about that task, like the context group you want to select, like dev, test, or prod. You can select and override context variables, like the amount of memory settings, or maybe some of the parameters. And you can specify the job server that it's running on. Great. Then you can go to an execution plan tab and say, okay, I want to orchestrate the execution of many tasks. You can create an execution plan to run a task, and if it's successful, run another task, or if it fails, run this task instead, and you can create this execution plan. But there's also a checkbox called Enable Parallelization, okay? Which means that you can create an execution plan that will run multiple tasks in parallel. Now, the nice thing about that is those tasks can be pointing to different job servers. So you can actually distribute the load across multiple job servers. because you know and understand that this job is going to take so much memory where that job isn't, but I still want to run them in parallel, and they can't necessarily run on the same job server, so I distribute them across job servers, put them into an execution plan, and run them in parallel. You can do that. Zero code required. Another example would be, I had a customer I was working for. We were processing 40 million records out of an Informix database. Each row had 2 blob columns of HTML and XML, which I had to parse and regurgitate out into other things. You're looking up images and reconstruing the XML. It was a massive undertaking. For 40 million records, that job took 6 weeks to execute. Well, but I designed it as a command line job. Said, okay, if I pass in some arguments like start and end date or start and end sequence number, I could chunk that data. Now, I've written that job so I can tell it which chunk of data to process. I can parallelize that. So I created 20 tasks on the same job, setting up different values to process in parallel. I distributed across 3 job servers. I created an execution plan running in parallel, 21 jobs. That thing ran in about 2 weeks. And that was before I went into any code to enable parallelization within the code. My predecessor, who I left behind, he wanted to follow me at Talend, but I left him behind at this customer. He optimized it even further to get it down to 4 days because he was running parallelization at 2 levels, in the execution plan and within the code. The next thing you can do is actually have multiple job flows. Remember the entry point, the box having the green background? When you think about that, well, what if I just had 5 of those within my job design? Can I do that? Well, yes, you can. And effectively, you're going to be spawning 5 different flows on the same JVM, essentially on the same thread. So it's not true parallelization, but it will allow you to run multiple flows. I don't like that particularly, but I take it one step further. Why not use that method, but called Talend Jobs? And turn on that box. Run an independent JVM. Now you can create a parent job that is effectively an execution plan with programmatic control. Because on the execution plan, you've got 0 programming, 0 code, but the trade-off is you can't make it smart. So if you need to make it smart, create a parent job that runs multiple threads by calling Talend job with that checkbox turned on. Now the downside is it's all got to run on 1 job server. Whereas on the other side, in the execution plan, you could distribute across multiple job servers. So there's your trade-off. Okay, next level down, we have components to enable parallelization. The T-parallelize component links multiple process flows within your job. So you can drop this component in and link up as many different process flows as you want. They can call Talend jobs if you want. They can do anything, and they will each have its own thread. So that is the way within a job to set up multiple threads from the same job. Again, it's all running on the same job server, and yes, you can be calling Talend jobs running in independent JVMs, so think about how you're going to orchestrate all this. That's a powerful component. So powerful that I recommend don't nest them. Don't put in a T-parallelize component that calls another T-parallelize component. Okay? Because this is the problem with parallelization. You can get yourself in trouble really fast. And I'll put one image in your head. Mushroom cloud. Okay? That's what you can do if you don't do it right. So, for example, in our 3-tiered orchestration, what if the parent runs T-parallelize, the middle tier calls T-parallelize, and the bottom tier calls T-parallelize? You don't know how many threads you've got. And it's all got to run on 1 job server? No. Put it at the top or at the bottom, wherever it makes sense. In addition, we have 4 components that work together. The partitioner, departitioner, collector, and recollector. These are going to enable data flow parallelization. So in our use case where we have 20 million rows, and we want to spin up 5 threads, we start off by doing our select statement. We put in a partitioner component. It asks us how many threads. 5. Thank you very much. You need the departitioner to pass it into a T-map, and a recollector. You need all 4 of these in the stream somewhere in order for it all to orchestrate and manage your threads. Okay, you can't get away with not using all 4 of them. So it means that you're creating extra components to generate the parallelization, but you can create all these threads and maybe optimize your code that way. Good stuff. Or you can right-click on the row, and a little menu pops up, and at the bottom of the menu it says use parallelization. You say yes, and you tell it how many threads and what your partition key is, and it will insert effectively the same code as those 4 components. And you can effectively generate threads on that 20 million rows without having to drop in components.
So you create, you parallelize, it creates this many, it's called parent-child children, and then you wait for all of them to sync up.
Sure. I don't have a sample, unfortunately, but let's talk about that offline. We got a couple things to talk about. So we can find some way of getting you some samples, right? Because it is tricky, right? So my intent here is to at least show you what's possible, and then we can have more conversations about the how, right? Okay, so there's something else I want to say about this, because these components can help or hurt. I had another customer, I like using customer examples, but I'll never mention names. It was an e-commerce website, and they were processing payments, and they had a data flow coming in. They had a T-map with 20, because they needed speed, because this was real time, right? They needed to process that payment and push back a message to the customer on the browser saying payment has been processed. They had 20 lookups in order to get the data through. They ran parallel 20 threads using the technique of right-clicking on the row. Okay, so it didn't create all these components. You can imagine 4 sets of components for 20 lookups. That's a lot. Okay, so they clearly didn't want to do that, so they used the other technique. Problem was, one of those 20s had a bug. We couldn't tell which one. Why? Because only the component throws the component error. So we had to go in and stitch in those 4 components on all 20 threads to run a debug session that found the one lookup that failed. We fixed it. We pulled out all those 4 components for each 20 threads to rerun the job, because by adding all those components, it slowed it down. It was 4 components times 20. That's a lot of extra code. So it made that much of a difference. We had to do it in order to debug and find the error, which we did. But then we stripped out those components in order to put it back into production and have it fast. And it was fast. I mean, seconds, they were getting the information back. That was pretty important. So there's the trade-offs of those things. And then the last level here is at the database component itself. Primarily, we're talking output components. If you go to the Advanced Settings tab, you'll find an enablement checkbox for using parallelization. And you can specify how many threads you want to use on inserts, updates, and deletes. Bulk loading, if you will, on just our standard output components. Recommended, use somewhere between 2 and 5 threads. You will find that if you're pushing 20 million records into a database table and you turn it into 2 threads, you'll probably do it twice as fast. You set it to 5, you're going to get it 5 times as fast, but there's overhead with threads. So pushing it to 20 doesn't necessarily buy you a faster performance. There's overhead for managing every thread. So there is a cost. And there's going to be a threshold level where you're going to have a reduced or diminished return on the investment of threading. So as a developer, you want to play with that, right? Try 2, 5, 10, 12, whatever works and gives you your optimal performance. You also want to look at your buffer sizes, right, and your memory allocation, and think about the job server it's going to run on. But I think you're going to find 5 is a good number. Maybe you bump it to 6, you still get better performance. You'll have to try, play with that yourself. Any other questions on parallelization? Yes? How many job servers? Sizing job servers is a different exercise, right? We talk about reference architecture, and we work with customers on defining and sizing the proper footprint for your dev test and prod environments. Number of job servers, how much memory on the job servers, how many cores, all of that. That's a big discussion. So there is no quick answer for that. Okay, and we have programs in our professional services team that come in and help you define that for your team. I think we've done that with Walgreens, for example, right? Where we stepped in and we helped figure that all out. So it's a complex question and a complex answer. But we have some guidelines on the KB articles, reference architecture guidelines. I kind of broke it down to a small, medium, and large approach to give you some basic ideas. For me, for that job that I did with the 40 million records, I did 3 job servers with 96 gigs of RAM each, 8 cores. And I never pegged the server except for the first time I ran it. Okay, let's wrap up. I think I'm probably over time a little bit, or? Okay. Other people that want to. I could stand up here all day. Nick knows this. All right, well, let's wrap it up. I appreciate the opportunity to dive into these, and great questions, by the way. I love that. So to have successful driven projects in Talend, just like any other software paradigm, you need 3 components. Another one of those 3s, right? Marcus Lemonis had one. Well, here's another one. Use case, technology, and methodology. Okay, you guys know your use case. You know your business, your requirements, what it is you're trying to build. The technology stack, thank you for having Talend be part of that. The methodology, we've talked about one today, SDLC. There's another one I call DDLC, which is the Database Development Lifecycle, which I talk about in my other blogs and in my new series on data modeling. So go read those for information about that. But you have to have all 3 things in order to have successful projects. Now, I finally reveal my number 1 foundational precept is consistency. Do it the same way all the time, even if you do it wrong. Because then it's easier to fix, right? So that's my number 1, top of the bill every time. Just do it the same way all the time, knowing that you're going to bend the rules along the way. But that's my preference, right? All those other ones matter, obviously. Functional first, performance second. I kind of prioritize those 2, but there you go. I love this quote from Pablo Picasso, a very creative genius. Action is the foundational key to all success. Now, what do you suppose he means by that? Say it again? Do it instead of talk about it. You're absolutely right. Just get it done. You can talk about it until you're blue in the face. And keep talking about it. Don't stop talking about it, but get it done. That's what I'm saying here. Create a center of excellence for the larger enterprises. Encapsulate these job design patterns, these best practices into your development guidelines. Do this to have the opportunity for success. I can't guarantee it, but it's going to make it a lot easier. Okay? So guidelines, not standards. Allow your jobs to bend and not break. Right? Pliable code. That's what I like. Reusable and pliable code. That's what we strive for. And back to that original question on why did I choose Talend over the others is because it allowed me to build pliable code. Very robust capabilities. And my last slide is just a series of do's and don'ts. We can just let this thing show up on the list. I'm sure you guys can come up with a dozen more. My team has come up with more too, but that's my short list of tricks and traps. So with that, I'm going to open it up to any remaining questions that you guys might have. Yes? Everyone who came today will get a PDF version of this. Absolutely. And I'll also include that handout, which I didn't have with me today. I'd like to usually pass them out, but I didn't get access to a printer in time. So we'll get you those two things. Yes? We'll take that offline. Okay. And any other questions? Yeah.
We talked about dynamic SQL, right?
Yeah.
How about the dynamic? So we need to define the SQL. We define the query, right?
Okay.
Dynamic schema concept.
Dynamic schema concept is different than dynamic SQL syntax, correct? So actually I addressed that one in my blog. I believe that's in part 4. So we can talk about it. We have a T dynamic schema component, and there's a trick to that. What happens is I get customers ask me, well, I have 400 tables, and all I need is a job that moves data out of that table downstream. Do I have to write 400 jobs because all the schemas are different? The answer is no. Then they ask me, well, can I write it in one job? And I say the answer is no, but you can do it in 2 jobs. I'll show you how, and I talk about that in the blog part 4. Okay, so you can do it in 2 jobs. Dump and load. All right, anyone else? Great, well, thank you all. Oh, one more.
You mentioned that not the version control the way you might have
Yeah,
nature version. So our company
okay.
apparently creates problems. Now I realize it creates problems. So what they should tell my development team not to do it.
Use the branching and tagging with the source code control system of choice, either SVN or Git. Tag versions and branch releases. So you do both a tag and a branch for a release. But if you want to increment the .1, .2, .3, tag them. It creates a snapshot,
That will require everybody access to the repository.
which they already have.
No, our developer does not have access to the repository, only the person or administrators.
They should never have to go into the repository directly. It's all integrated into the studio. You branch and tag from the studio. Correct. There's a little icon, a special icon you need to learn how to use that allows you to do branching and tagging and selecting the branch and tag you want to work on within the studio. You don't have to do anything outside of the studio. I think I'm going to stop now, but thank you all very much for giving me the opportunity to come to Chicago again. And I'm happy to talk to any of you afterwards, one-on-one. I'll be here all day. Thanks again.